Let's design an API rate limiter for an application handling thousands of requests every second. The idea is simple. A user can call your API to perform some action, but each user is only allowed to make 100 requests per minute. If they go above that limit, the server should reject the extra requests. The most obvious way to build this is using a counter. For every user, you store 3 things: their user ID, the number of requests they've made, and the current minute. Every time that user sends a request, you increase the counter. Once the counter goes above 100, you reject any new requests until the next minute begins. This is called a fixed window rate limiter, and for simple systems, it can work perfectly fine. But there's a problem. Imagine a user sends 100 requests during the very last second of the minute. Then 1 second later, a new minute begins. The counter resets back to 0. Now that same user can immediately send another 100 requests. So technically, they followed your rule of 100 requests per minute. But your server just received 200 requests in roughly 2 seconds. Now imagine another user sends their 100 requests at the beginning of the minute. They immediately hit the limit and could be blocked for almost an entire minute. So 2 users with exactly the same rate limit can experience completely different behavior depending on when they send their requests. That's the weakness of a fixed window counter. It watches the clock more than it watches the actual traffic. A better solution is something called the token bucket algorithm. Imagine every user has a bucket containing 100 tokens. Every API request costs 1 token. When a request comes in, you remove 1 token from the bucket. If there are no tokens left, the request gets rejected. But here's the important part. Instead of resetting the entire bucket every minute, tokens are continuously added back over time. If your limit is 100 requests per minute, you refill roughly 1.67 tokens every second. So a user with a full bucket can still make a burst of 100 requests. But once those tokens are gone, they have to slow down and wait for new tokens to appear. For example, if someone consumes all 100 tokens immediately, they can't suddenly send another 100 requests when the clock changes minute. They can only continue at roughly the refill rate. And if another user sends 100 requests near the end of a minute, the exact same rule applies. There is no magical reset. Now there's another problem. What happens if your application runs on 20 different servers? One request from the same user might reach server number 3, while another request reaches server number 12 at almost exactly the same time. If every server keeps its own rate limit counter, they could all think the user still has tokens available. So instead, you store the rate limit state in one shared system, usually something extremely fast like Redis. Each server checks and updates the same bucket, and for each user, you really only need to store 2 important values: how many tokens they currently have, and when the bucket was last updated. From that timestamp, you can calculate how many tokens should have been refilled. So when you think about rate limiting, don't just think 100 requests per minute. Think about 2 separate things: how large a burst you allow, and how quickly that capacity regenerates. That's the idea behind the token bucket rate limiter.